Welcome to The Explainer. Listen, if you were around in the early 2000s, you absolutely remember the total circus surrounding Grand Theft Auto 3. I mean, it was a cultural earthquake, right? But if you look back at how the legacy media actually covered it at the time, you'll realize they completely missed the real story. They were so busy losing their minds over the on-screen chaos that they literally ignored the impossible magic trick happening right under the hood. Okay, let's dive into this. The news cycle back then was just this massive, pearl-clutching moral panic. You had reporters acting like the game was some digital training ground for sociopaths. But while politicians and pundits were hyperventilating on television over the subject matter, they were completely blind to what was genuinely groundbreaking here. It wasn't the violence, guys. It was the code. The real story was an absolute engineering sleight of hand that, frankly, shouldn't have been possible. Just look at this impossible math for a second. On one side, you've got Liberty City, this sprawling three-island metropolis packed with hundreds of unique buildings, thousands of textures, pedestrians, cars, the whole shebang. All of those assets combined, roughly 130 megabytes of data. On the other side, you have the PlayStation 2's total internal memory, a tiny, microscopic 32 megabytes. You definitely don't need a computer science degree to spot the problem here. You literally cannot fit 130 megabytes of city into a 32 megabyte box. So how on earth did Rockstar North pull it off without sacrificing the scale of the world? Part 1. The hardware bottleneck. To really understand this bottleneck, we have to look at the PS2's massive data divide. Up until this point, traditional game design basically meant you loaded a level, played it, and then sat staring at a loading screen while the console wiped its memory for the next room. But for a seamless open city, no doors, no loading zones, that method was completely useless. See, the game disc itself, the DVD, held a whopping 4.7 gigabytes. That is plenty of room to store the entire city. But the DVD laser reading that disc was painfully slow, turning out maybe 5 or 6 megabytes per second. Way, way too slow to pull data directly while you're speeding down the highway. Meanwhile, the internal RAM was lightning fast, moving data at 3.2 gigabytes per second. But again, it was capped at that microscopic 32 megabytes. Everything you see on screen had to be violently funneled through that tiny space. Now, the easy way out would have been to just make the game ugly. Use low-res textures, super basic shapes, and just cram the island into 32 megabytes. But technical directors Albe Vermey and Adam Fowler knew that would make the city look completely bland. So instead, they engineered an incredibly ambitious solution called streaming. Basically, they created an invisible, moving window right around the player. As you drove down the street, the game was secretly grabbing assets from that sluggish DVD, building the world just out of sight in front of you, and then silently deleting it right behind your back. If you ever played this back in the day, spun the camera around really fast, and saw a building just pop out of nowhere, yeah, this is exactly why. You were essentially surfing on a localized, moving bubble of loaded memory. Part 2. Maintaining the illusion. And this brilliantly illustrates the next big headache. Having a moving window of reality is awesome, but it creates that dreaded last-generation issue, pop-in. If the game only loaded the block you're standing on, Liberty City would look like an empty void with buildings just magically popping into existence right in front of your bumper. To fix this and maintain the illusion of a massive permanent skyline, they built a level of detail, or LOD system. Step 1, the immediate area around you is fully loaded in high-res. Step 2, for stuff far away, the game ignores the small details and swaps massive structures like skyscrapers and bridges for imposters. These were basically super simple low-poly models with pretty crummy textures. Step 3, as you drive closer, the game streams in the real, high-res building and gracefully fades it right over the imposter. It saved a huge amount of memory while tricking your brain into believing the whole city was always there. But wait, because the math gets even tighter here. That 32 megabyte pool, it wasn't just for the buildings. It also had to hold the pedestrian AI, the physics calculations, character animations, player status, literally everything keeping the game alive. Once you subtract all those mandatory background systems, the actual amount of memory left over to stream the entire sprawling city of buildings, roads, and textures was a shockingly small 13.5 megabytes. Oh, and we can't forget about the cars. Vehicles eat up a lot of memory space. With only a sliver of RAM left, Rockstar had to implement a ruthlessly strict memory pool for vehicles. Literally, only 8 unique car types could be loaded into memory at any given second. One slat is your car, another is the last car you drove. Throw in a cop car, a taxi, and whatever happens to be parked nearby, and you're maxed out, which perfectly solves that spooky 20-year-old gaming mystery. Why does everyone in the city suddenly start driving the exact same rare sports car the second you finally find one? Well, because your new car just hijacked one of those precious 8 slots, making the game engine highly likely to just recycle it and spawn it everywhere. Part 3. Duct tape solutions and clever hacks. When your budget is this tight, traditional programming just goes completely out the window. We're shifting away from standard development and entering the realm of rapid fire, almost desperate micro-optimizations required to keep the PlayStation 2 from completely crashing and burning. The biggest villain here was memory fragmentation. Think of it like a bookshelf where you're constantly swapping out thick books for thin ones. Eventually, you're left with dozens of tiny gaps. They're too small to fit anything new, but collectively, they waste a ton of space. If the game's memory fragmented too much, the console would just die. Adam Fowler literally used to tape the controller down so the game character would ride the city train overnight. He'd leave it running on 5 development kits, praying the game wouldn't crash. And at first, they died in about 5 minutes. Now, what's really interesting about this slide is the sheer creativity of the solutions they came up with to survive the night. It's amazing. Fowler wrote a custom memory manager that constantly shuffled these blocks around to merge the empty gaps. They even forced the artist to standardize over 500 game files to be exactly 2 kilobytes, and over 400 files to be exactly 4 kilobytes, so they would slot right into each other's empty spaces perfectly, like puzzle pieces. But honestly, my favorite hack? They actually copied and pasted the exact same 3D model of a trash can onto different physical locations on the DVD itself. Why? Because it was literally faster to have the physical laser read a duplicate trash can right where it was, rather than wasting precious milliseconds seeking across the spinning disk to find the original file. Part 4. The invisible speed governors. So, all these streaming trucks depended entirely on the physical DVD laser actually keeping up with you. But what happens if you jump into a sports car and drive faster than the mechanical laser can physically read the disc? Absolute danger. You literally outrun reality. The game wouldn't be able to stream the street fast enough, the collision detection would fail to load, and their car would just drop right through the asphalt into a terrifying, endless void beneath the map. If you played back then, you definitely know this as the blue hell. To stop players from plummeting into the abyss, Rockstar had to get sneaky. They implemented these invisible speed governors. First, they enforced strict maximum speeds on all the cars. But in certain parts of the city where the streaming really struggled, they would secretly increase the air resistance on your vehicle by just a few percentage points. You couldn't even feel it happening, but it slowed you down just enough for the laser to catch its breath. And get this, on Portland's Main Street, there was a straightaway that was just too long. Players were building up way too much speed. So what did the developers do? They literally just dropped a massive, unavoidable building right in the middle of the road to force you to hit the brakes and swerve around it. Part 5. The myth of the Dodo. All right, understanding this streaming engine perfectly sets us up for our finale. We're going to take everything we just learned about memory fragments, struggling lasers, and speed governors, and we are going to bust a massive 20-year-old pop culture myth. If you played this game, you know about the Dodo. It's the only airplane in Liberty City, but its wings are clipped, and it is famously, frustratingly impossible to actually fly. Now, because GTA 3 came out right around the time of the September 11th attacks, a rumor immediately started that Rockstar intentionally nerfed the plane at the last second. The media narrative was that the developers censored their own game to prevent players from emulating real-world terrorist attacks by flying planes into Liberty City's skyscrapers. It's a rumor that has survived for over 2 decades. So the crucial point is, that rumor is completely 100% false. It wasn't some noble moral stance, it wasn't late-stage censorship. The cynical reality is just that the game engine simply couldn't handle the Z-axis. If you flew high up into the air, you would immediately outpace that disc laser. Even worse, to save memory, half the buildings in the city didn't actually have roofs, and the interiors of city blocks were just empty blue voids. Exposing the player to the air would have revealed the entire magic trick as a hollow movie set. They grounded the Dodo because the PlayStation 2 would have quite literally burst into flames trying to render the sky. Squeezing an entire 130 megabyte metropolis into just 32 megabytes of memory is, it's nothing short of a developmental miracle. It required duct tape, invisible speed limits, duplicate files, and completely rewriting the rules of game design. The legacy media looked at this thing and saw nothing but a shallow controversy simulator. But the real legacy of this code? It's a masterclass in optimization that paves the way for every massive open-world experience we enjoy today. Kind of makes you wonder, doesn't it? What other pieces of controversial media out there are actually just hiding brilliant world-changing engineering right beneath the surface? Thank you for joining me for this explainer, and hey, keep questioning the code behind the headlines.